Hello and good afternoon friends, welcome to CEC Live Lectures. Dear friends, today in this session we are going to talk on our series on disaster management, and specifically we are going to talk on glacier and snow avalanche induced disaster. And for this very discussion we have once again with us in our studios Professor R.B. Singh. Professor R.B. Singh is a renowned professor of geography. He is currently teaching in the Department of Geography, Delhi School of Economics, University of Delhi. Friends, if you want to ask questions from Professor R.B. Singh on today's topic, that is glacier and snow avalanche induced disaster, then you can call us right in the CEC studios. You can contact us through our toll-free number. Our number is 1-800-110-430. I repeat, our number is 1-800-110-430. Friends, you are requested to call in the last 10 minutes of the lecture so that you may get the in-depth knowledge on today's topic, and afterwards we promise to give you answers of your questions from Dr. R.B. Singh. So let's welcome our guest Professor R.B. Singh and let's try to have deep insight into today's topic. Hello sir, welcome to the lecture.
Thank you Gitika ji. Welcome viewers. Today we are going to have discussion on glacier and snow induced disasters. This disaster is a very unique because it is so sudden, it is so quickly that very difficult to develop any mechanism, response mechanism. So we will try to see different situation, different interlinked areas, glaciers environment, also how these glaciers and snow cover is influenced by climate change, what type of sign and signals we are getting in different part of the world in general and Himalaya in particular. You can see here that Himalayan glaciers and forests, these are the two very important, and Himalaya is generally considered as a water tower. So it is very important for sustainability of not only in India but whole South Asia. Mountain glaciers now attracting importance particularly for tourism activity, skiing, paragliding, variety of other activity are linked together with forest related tourism, and what I would like to use the word ecotourism. High mountain glaciers are also a spiritual significance, and you can see this photograph, Mount Kailash, most sacred mountain in the world for nearly 1 billion people in Asia, not only for India but people from Nepal, Bhutan, they also go and visit this. Now we would like to take the effects of snow and ice, and particularly here you can see the Arctic Sea environment, and the few important figure I would like to put before you. You can see the 1979 to 2000 average, the aerial extent million of square kilometer, and 2007 and 8, and you can find that from the 1979 2000 average, gradually decreasing the size. Here I would like to put before you a situation of different mountains of the world, and particularly I would like to mention here Europe, Andes, Arctic, Asian high mountains, Northwest United States and Southwest Canada, Alaska coastal mountain, and Patagonia, and you can see that how the glacier mass balance is gradually decreasing starting from 1960 to 2000. So certainly here one can see a close connection and linkages between climate change and glacier retreat or changing nature of glaciers. I also am putting another data and diagram coming from a very famous nature reports. Now, what is the impact of all these things? As you know, most of the biodiversity exists in the Himalaya or other mountains of the world. I am putting here the data about the Global Center for Species Richness, and you can see that in different mountain zone, diversity zone, number of different type of the plant species exist, and so if something happening to the snow cover or glacier will have certainly impact on the biodiversity. Now coming to the avalanche. The avalanche constitute a major hazard in a snow cover mountainous region in general and Himalaya in particular. It is a rapid down slope movement, I quote, of a large detached mass of snow, ice and associated debris such as rocks and vegetation. As per the NDMA 2009, a small scale avalanche occur in large numbers, while large avalanches occur infrequently, but causing most of the devastation. Such event may encompass slopes a kilometer or more in length with millions of tons of snow and result in massive destruction of forest, property and loss of human life. Humans have been facing the threat of sliding snow since long in the mountainous region. A large avalanche can run for many kilometers. Avalanche normally occur during a very short time period of 1 or 2 minutes, and it is very difficult to respond immediately unless and until one is equipped adequately. So, it is very important that the people going in that region should be very well equipped for protecting and preventing themselves. It is very important to know the types of avalanches. There are 2 basic types of avalanches, and then I will discuss also some of the subsets. Loose snow avalanches and slab avalanches. Loose snow avalanches form in snow masses with little internal cohesion among the individual. It occurs in large number. Such an avalanche originate at a point and develops wider as it gathers up more snow in its descent. Now you can see this photograph also. Now slab avalanches, you can see this trigger area, then a starting zone, crown, flanks, bed surface. These are the different processes. It originates in a snow with sufficient internal cohesion to enable a snow layer to react mechanically in single entity for a longer length. A slab avalanche breaks free along a characteristic fracture line, a sharp division of sliding from a stable snow whose face stands perpendicular to the slope. Then we can also have dry snow avalanches. This is composed of dry snow usually generate a dust cloud when the sliding snow is whirled into the air. Such slides, called powder snow avalanche, most frequently originate as soft slabs. Under favorable circumstances, enough snow crystals are mixed with air to form an aerosol which behaves as a sharply bounded body of dense gas rushing down the slope ahead of the sliding snow. This wind blast can achieve high velocity to inflict heavy destruction well beyond the normal bounds of the avalanche path. Then we have the wet snow avalanches. move more slowly than the dry ones and are seldom accompanied by dust clouds. Their high snow density can induce enormous destructive force in spite of lower velocity. Climax avalanche, these are triggered by a series of snowstorms or culmination of weather influences, very complex phenomena. Their fall is not necessarily associated with a current storm or any weather phenomena. Now, it is very important to mention the two very important institutions, NDMA, that is the apex body of the National Disaster Management Authority of Government of India, and a snow and avalanche establishment of DRDO. They contributed very substantially on the monitoring, predicting, and rescue and other mitigation measures. I would like to take to some of the driving factors mentioned by NDMA. They have mentioned the different type of multiple factors. First one is steep slope, that is a very important. A snow avalanche may occur on any slope where enough snow is deposited in the right circumstances. Most avalanche of dangerous size therefore originate on slopes with inclination of between 30 degree to 45 degree. Even more than on slope from 45 degree to 50 degree. Small avalanches are very common. Convex slopes are particularly more susceptible to avalanches than the concave slopes. Then snow cover, maybe the size. When the snowpack becomes unstable, it is released suddenly and descends rapidly down slope. So, this process, a snowfall of 1 meter in one day is far more hazardous than 1 meter over 3 days. So, a snow cover, this occur in a very complex topography. I am putting before you this complex mountain topography, and you can understand from own perception the type of issue involved in this. This is also a climatic phenomena. It is not only apart from the landscape, it is also more is a climatic phenomena. A weak layer in the snow cover is another important. Slab avalanche originates snow with sufficient internal cohesion. A slab avalanche breaks ice along a characteristic fracture line, and it is very important to understand also the different type of triggering mechanism. It may be ice fall, it may be earthquake, rock falls, thermal changes, blizzards, and even other avalanches are the common natural triggering factors. These are some of the inducing factors. Avalanche can also be triggered by loud sound such as shouts, machine noise, and sonic booms. In the absence of external triggers, unstable state may revert to stability. So, slope is a very important. Triggering mechanism is the second important. Then a snow cover and a type of layer is also important. It is very important to see the different type of the impact of a snow avalanche. Human structures can be damaged or destroyed due to the forces generated by moderate or large avalanches. Debris from even a small avalanche is enough to block a highway or rail block. A structure are not specifically designed to withstand these impacts are generally totally destroyed. So, landscape structure is a very important aspect in this context. Where avalanches cross highways, passing vehicles can be swept away and destroyed, so killing their passengers. In the past, several such things happened, in mid-90s in Kullu Valley. Whole even building of Sase was totally washed away, just a very short distance from the Manali area. Avalanche are extremely destructive due to the great impacts of rapidly moving snow and debris and burial of areas in the run root zone. Now, I would like to take some of the important signs and signals we are getting, particularly in the form of climate change. Changing global mean temperature, you can see this through diagram. I taken the data, IPCC data, Intergovernmental Panel on Climate Change, 1860 to 2000, and you can see that how rapid increase of global mean temperature we are getting. Same thing happening in the Himalayan countries like India, Nepal, Bhutan, and we are also getting this problem. Now, I am taking for the whole IITM data for the whole India, and you can see this type of variability we are getting between 1725 to 2000. And after 1800, more specifically the 1900, you can find not only the climate change, but the climatic variability. Climatic variability is the most important phenomena in this context. And so, you can see this the photograph coming from Dhaulagiri, Nepal Himalaya, that is a 8,167 meter mountain regions particularly sensitive to climate warming. So, most of the mountain regions and Himalaya in particular are very sensitive to the climatic warming. Temperature sensitive cryosphere, a steep terrain, particularly these two both are very important and appropriate for the Himalaya, compressed ecological gradients. So, it is very important to understand the altitudinal gradients and transects in order to understand the clear cut mechanism, and on that basis it is possible to have develop some typology or different type of the model on the basis of topographical gradient. I am taking here the retreat of Mer de Glace Glacier, French Alps, left side, an extension in the 1850. Now, you can see that how changes is taking place. This is a very visible. The data, it is a 1644, and then the later on the more current one. Kilimanjaro, Tanzania is a very famous, where also you can find this is the photographs taken from NASA, and Muir Glacier in Alaska. Both places, as I have discussed earlier, that how the whole glacier mass balance in declining in this region. Then it is very important to analyze the consistent pattern in the species richness, particularly the upslope range expansion to cooler elevation. Now, you can see this data change in the species richness per decade, and you can see the continuously we have declining figure. Tree line respond. Tree line is generally considered is a very appropriate in response to the climate warming. You can see St. Arnaud Range, New Zealand, particularly where in the case of Himalaya also we have a very typical type of the picture emerged recently, and tree line, due to the glacier retreat, tree line also the increasing. Tree line is a very important indicator also to understand, to analyze the glacier retreat or changing nature of the glacier. Here you can see this the global map, Hers et al. 2010, analysis of 166 tree line sites across the globe, and they found 52% advancing, including Himalaya. You can see also this the Alaska area, the Canadian and the US Rockies, Andes areas, everywhere Alps you can find, even in the New Zealand, 47% stagnating and 1% recession. This is the data, little data. Now, it is very important to understand the type of wetlands exist in the, particularly the lakes, glacier lakes in the Himalaya. You know, we have many lakes all over the Himalaya, but particularly I would like to mention about the Ladakh Himalaya. Many such lakes, mostly in the Changtang region, average altitude about 4,700 meter above sea level. Temperature varies between 27 degree to minus 40 degree. Unique and very fragile ecosystem. Fresh water as well as brackish water for varying salinity and size. You know, in such region, people are not only going for tourism, particularly I would like to mention about this, the two important wetland, Sumori and twin lakes, Sokor and Starspuk show. You can see this, the photograph, glacier and wetland interface, Sumori here. It is very important, appropriate to analyze the GLOF, Glacier Lake Outburst Flood. This is a very, hope you will remember, few years back in Himachal Pradesh, this very important disaster occurred, Padachu, it is called the Padachu Lake Outburst. Particularly, I would like to mention in India, we have the two regions, this problem exists, Glacier Lake Outburst flood. We have more probability, Himachal Pradesh and the Sikkim area. Sikkim also we got some, you know. Here you can see the cross section of the globe. We have the glacier and then avalanche prone area is there. Then we have the vacant space due to the glacier receding, lake exists, and then other side we have the moraine dam, and then suddenly we get lake outburst flood, causing a lot of damage to the far distance places, because there exists highland lowland interactive system, upstream and downstream relationship. Any problem in the upstream causing a problem to the downstream. I would like to mention also that this phenomena has hydrological significance, particularly lowland in the river basin. You can see how hydrologically important mountain regions in different part of the world, and you can see this very broadly speaking. I would like to say that only 10% people live in this mountainous region, but almost 40% people are depending on different type of resources, particularly the water and the forest. Through this photograph, I am putting before you this the how glaciers and Indo-Gangetic plain. So, the flooding in the Indus, Ganga system and Brahmaputra system. This the all instability in the upper part of the Himalaya or the upper Himalaya, you can say, due to the changes in the climate and the changes in the glacier. In short term we can get flooding, and in long term we can get the shortage of water, like a drought or the scarcity of water. So, these both phenomena one can see. So, high flow, even high flow season we have the flooding. As I mentioned while discussing about this the lakes, you can see this the how transhuman community they are more dependent on these type of the lakes. They get adequate food or drinking water and variety of for the animal drinking water for the animal, they all get from these lakes. But in recent years we are getting the problem in such lakes due to the sedimentation and also the changing nature of the glaciers. I would like to quote a few lines from the IPCC 2007 Intergovernmental Panel on Climate Change. I quote, "Glacier melt in the Himalaya is projected to increase flooding and avalanches from destabilized slopes and to affect water resources within the next 2 or 3 decades. This will be followed by decreased river flow as the glacier recede. It is projected that crop yields could decrease up to 30% in the South Asia by the 21st century, according to the Intergovernmental Panel on Climate Change." What are the impact of these climate change? Variable rainfall, melting of glaciers, and then subsequently increased runoff, excessive flooding. We have also the discharge, increase of discharge, and then water scarcity. And when we will have the water scarcity, we have decreased agricultural productivity, and then impact of health of flora, fauna, and more specifically human beings. At watershed level, it is very important to see here also to analyze the uncertainty at the watershed level. Vegetation cover drive hydrology in the mountainous area. I would like to mention that if you analyze in the Himalayan scale, micro level factors like rainfall is a very important. But when you come to the catchment level, you see then the vegetation cover is a very important. Vegetation used to control the runoff process in the area, and so subsequently we will have a lot of changes in the water. Another important impact I would like to mention about the forest and dams. And forest means biodiversity. Like you take India, we have the 2-3 important biodiversity hotspot exist, many in the northeastern state, particularly the biosphere reserves, and Nanda Devi Biosphere Reserve, Valley of Flowers. These are the 2 very important exist in the Himalayan region, and largely they get water from these glaciers. So survivability of forest and the people living in that area, largely depending on these glaciers. I would like to also mention about the dams. Any instability and the changing nature of glaciers can influence the existence of the dam. These are the very important. Dams are very important for creating self-reliance in our country. So I would like to conclude here the first part of my talk. Thank you. Welcome viewers. In this part, I would like to especially mention about the glacier and snow avalanche induced disaster taking into consideration of Himalayan experience. First, I would like to mention about glaciology versus geographical diversity of Himalaya. A snow-clad region, important characteristics, tallest water tower of the earth, rich geoheritage, seasonality in climate, diverse environment, arcs and architecture, and many landscape attraction. Now you can see more than 1 billion people depend on water from diminishing Himalayan glaciers. So, any changing nature of glacier can influence the water availability in the low-lying area. Now you can see here this population density how exists in the Himalayan region, and particularly I would like to mention about here Brahmaputra plain, Ganga and Indus. Now I would like to mention very quickly avalanche prone areas in India. Himalaya, well known for the occurrence of a snow avalanche, particularly Western Himalaya, Jammu and Kashmir, Himachal Pradesh and Western Uttarakhand. Now you can see this the snow cover area of India. Most important vulnerable area from Jammu and Kashmir, higher reaches of Kashmir and Gurez valleys, Kargil and Ladakh, and some of the major roads. Himachal Pradesh, Chamba, Kullu Spiti and Kinnaur, Western Uttarakhand, Tehri Garhwal, Chamoli district, North Sikkim, Kathgodam Nainital, Garhwal Himalaya including Jamuna Valley, Satluj Valley in Himachal Pradesh. These are some of the important. Now here I would like to take the two maps prepared by one by a snow avalanche points of the Sase, particularly in the climatic zone. They have divided into the lower, middle and upper Himalaya, and some of the important sites already mentioned, and particularly I would like to mention that the middle and lower Himalaya is a very important because people are living very closer to that area. Now you can see natural hazard signs, that another map, the more important occurrence zone in the Himalayan region. Three types of snow avalanche zones are in Himalaya. First, red zone. This most dangerous zone where snow avalanche are most frequent and have an impact pressure on more than 3 tons of per square meter. Again, blue zone, this is a more moderate type of where the avalanche force is less than 3 tons per square meter, where living and other activity may be permitted. Construction of safe design, but such area may have to be vacated on warning. Third, yellow zone, where snow avalanches occur only occasionally, so not much. Now here you can see some of the important data I am putting from all over the world, and you can see this loss of damage caused by a snow avalanche in 2015, and in Asia region 2,858 deaths occurred, followed by Europe 1,201 death, and you can see loss of million in dollar if you see, then you have in Europe 775 million, and then in Asia probably due to the low economic condition, particularly per capita income and all, we have the less loss, particularly in the billion. But if you see the number of events, so 51 events occurred in Asia in 2015, Europe 33, America 4, Oceania nil, Africa nil. So, these are the 3 important continents, particularly the Asia, Europe and America you see very less. I would like to discuss 1-2 important case study and disaster what occurred in recently. In January 2017, a snow avalanche in Jammu and Kashmir killed 15 Indian soldiers. During 16 to 20 February, a snowfall of up to 2 meters occurred at many places in the higher reaches of the Pir Panjal range, resulting in avalanche at several places in Anantnag, Doda, Poonch, Pulwara and Udhampur district of Jammu Kashmir. Over 300 people lost their life. I would like to mention particularly Gurej snow avalanche that was occurred in 25th January 2017. Then first avalanche hit Gurej on 15th of January morning, in which a family or 4 civilians died. The second took place around the same time in Sonmarg, chiefly a tourist area, very famous, where an army camp was located. In the evening, 2 avalanche again hit the Gurej valley, roughly 150 km from the Sonmarg in quick succession. Here I would like to mention that in quick succession avalanches may cause more damage. This is the photograph of the 2017 from different agency. This is the photographs given. Rescue efforts, even a small avalanche can present a serious threat of life. According to SASE, as you know, Snow and Avalanche Study Establishment, Chandigarh, and I would like to mention that the main building was near Manali, few kilometers just from Manali, and in 1995 a big avalanche occurred, and cloud burst, and then in combination with the other factor, flooding and all, and the whole building washed away. Then they shifted to Chandigarh also. The percentage of survivor depends on the response time. It varies from 92% for a response time of 15 minutes to only 30% for a response time of more than 35 minutes. This is the data done by the SASE on the basis of several examples. The survivors among the victims are the first responders. So, you can understand from your perception that in such situation very difficult to rescue operation operated from outside. So, only those who are living in that area, they are the first responders, and sometimes survivors are the first responders. When victim carrying and use a standard avalanche safety equipment, it increase chances of a buried victim being found alive and being rescued increase. I would like to mention about the some of other interlinked elements, and one I am taking the snout recession, and you can see the how starting from Siachen, Milan, this Gangotri, Bhagirathi, all different type of the work done by the different people, and you can see these Chota Sigri glaciers. Everywhere we have a average snout retreat starting from almost 5 meter to 36 meter. 36 meter we have in Milan, particularly period between the 1990 to 2006. So, we have a many auster data collected by the many organization, and they are doing the work, and found that we have some retreating nature of glaciers. Now you can see this is the little bit old data taken from the Advanced Spaceborne Thermal Emission and Reflection Radiometer, and you can see how from 1780 that data largely taken from topo sheets and all, and then the current 2001 how decreasing the area of the Gangotri glacier. And what happens after that? You can see moraines in the river valley. These are the, you can see the one can observe the moraines in the river valley indicating glacier retreats. Snout of glacier, Gangotri glacier, which has exposed in the area of periglacial activity after its retreat. I would like to take up some data for the two very important center, Chamoli and Pithoragarh. Two center I would like to take the data of the seasonal mean maximum temperature in order to support of my a statement not only globally climate is changing, but also within the Uttarakhand and Himachal Pradesh also we collected the data for Bhuntar and Manali area and found that the some changes in the. Now you can see 1955 to 2002 0.6 degree centigrade changing, particularly during the winter time, and post monsoon time 0.6 degree centigrade. Here you can see annual maximum average temperature of India 1901 to 2007 this data, and you can see this the how temperature increasing, and immediate impact of temperature can be seen on the glaciers or a snow cover area. Here we collected the data for changing of the glaciological parameters, particularly taking the three glaciers, Tipra Glacier, Dhawnagiri Glacier and Milan Glacier, and particularly I would like to take the data of 1962 and 2010, and then we will try to see the change. Area, not much change in all three. Length change occurred, if you will see this length except the Milan we have the change. Mean width in kilometer, particularly you can see in the Milan, in the case of Milan. Altitude of a snout also we have changes in all cases except Dhawnagiri, not much change. Elevation also the ranges, because in elevation region of Tipra is 3800 to 5500 and Dhawnagiri is a little less range, and here is the map. Retreating snouts of Milan, Dhawnagiri and Tipra glaciers, and green color you can see this is the bucketed glaciated area. So, now you can understand that how much impact this retreating nature can bring downstream. Here I would like to put before you the major observation, and particularly I would like to take the case of the Nanda Devi Biosphere Reserve, because I am discussing the Nanda Devi Biosphere Reserve area where I supervise this PhD work. The response of glaciers in the form of retreating snouts to global warming are very different in different. Very broadly speaking, in the central Himalaya we have the more retreat in comparison to western Himalaya. Many local factors such as local physiography, orientation, slope of bedrock, order of a stream have important influence on the glaciers. Paucity of relevant information related to climatic condition and glacier parameters renders glacier study very difficult. And so, apart from temperature, decline of a snowfall is important. We conducted the primary survey asking from the people, and they found that they are getting the changing nature of a snowfall. Here you can see this dead glacial mound and melting from beneath, making the surface collapsible. This indicates this is an indication of a slated glacial ice melt. Then the changing landscape, particularly confluence of Rataban and South Nilgiri glaciers. Here you can see the well established moraine in both sides of the Gauri Ganga river emerging from the Milan glacier. You can see this in the data. We got the lot of changes, record of glacier recession and changing landscape. Changing here, I am putting the all changes in the one map, like a Donagiri, Tipra, and you can see this during 62 to 1210, 12.5 in case of Donagiri, 1.7 meter in Tipra, so very less, and 43 meter in Milan. This is the changes in snout. Here you can see the changing extent of glacier lakes. This is also the another new example of indicates the impending climate change, or what we are getting impact of them. These are the some of the important lake type, latitude, longitude, area, and you can see the changes, particularly the square meter in this area. So, we have substantial change. Here we have the a map of the particularly Gipang Ghat Glacier Lake area. Now, it is very important also to mention about the list of the major hazardous event: avalanche, debris, slides, flow, globe and rockfall. So, glacier induced different type of the in Nanda Devi Biosphere Reserves. In 1936, 48, 52, 75 in Badrinath, particularly rock falls accompanying with avalanches. 79, 2002, this Bamni village near Badrinath, avalanche blocked river for few hours. 70s, Hanuman Garhi area. 15 July 2004, Badrinath. 14 July 2007, Alkapuri Glacier. 2005, Govind Ghat. So, more recent is at 14th July 2007, Alkapuri Glacier near confluence of Satopant and Bhagirathi Glacier. This maybe you can say a glacier lake outburst flood, and here I would like to just describe that the glacier fluvial sediment were deposited in Alaknanda river. Large area of Lakshmi 1 was damaged. I would like to take few case study from the western Himalaya, particularly the Himachal Pradesh, and you can see that the first I would like to put before you the map of, and you can see the eastern side we have the more change, aerial change in the forest in the glacier cover than in the west area, or extreme west we have, but in middle part we do not have the much area. So, particularly snow area plus 8, that was the 8% increase. The percentage change is in respect to the total geographical area, and so altitudinal variation in the region has impact on decrease in the snow area also. You can see this potential globe site in this Himachal Pradesh. This another PhD work supervised by me, particularly the looking the upper part of Himachal Pradesh, identifying the globe sites and what will be the impact. of all these glacier induced disaster, rock falls and snow avalanches, all will have the increase of discharge of the rivers, and many places we get the sign and signals for that. And then you can see here flood frequency, how the flood frequency is increasing in the Brahmaputra region less, but Ganga region and Indus region. So, what we can do? Monitoring, prediction and mitigation. Particularly, I would like to use the word ungauged basin. Himalaya is considered as an ungauged basin. It is very difficult to obtain required information from the remote regions of the Himalaya using conventional ground based technique, and the ground data is also declining. So, Landsat, IRS, Aster, MODIT, GRACE, field observation, GPS, other SRTM, other type of the data can be taken into consideration. So, I would like to tell that satellite remote sensing as an appropriate tool in this context, and for gathering the latest terrain information on avalanche prone area, snow cover and parameters, particularly optical like MODIS, AVHHR, WIPS, AWIPS, WIPS, these three, PAN, cartographic cartosat, ECONOS, microwave. Particularly microwave I can mention here, that where in such situation where weather condition is and cloud cover is there, this may be the very useful. Here we tried to prepare the map of the geohazards along river Spiti and Satluj after the globe. This totally done on the basis of the field survey, and we tried to find the history of the avalanches, history, rock falls and other phenomena in this map. Here we did the vulnerability assessment in the Uttarkasi region, and we combined here the flood vulnerability, landslide vulnerability and avalanche vulnerability. All together can be combined under the geographic information system, and we can say to the planners and decision makers like where we have very high probability, where very low probability. You can see here distribution of potential danger glacier lakes identified for the upper part of Himachal Pradesh. So, in this context I would like to mention that the early warning system is very important in this, but early warning is also
sorry to interrupt you,
yes.
Sir. We have a caller right now. Hello. Hello. Hello.
Hello, ma'am.
Yes, please tell your name and ask your question.
My name is Pawan. I am calling from Varanasi.
Yes,
Madam,
Pawan.
my question is why glacier and snow avalanche take place, and how we can minimize this disaster?
Fine.
Thank you.
Thank you for calling us. Yes, sir.
I am coming to that, particularly the mitigation. Avalanche control strategy is very, early, we have to develop the early warning mechanism, and I would like to tell you it is so quick that as I mentioned, that the only survivors are the first responders. So, the well equipped a person can save themselves from such event. I would like to mention that there are several factors responsible for that. A snow cover, slope, a snow cover on the slopy area, and triggering mechanism. It may be due to the climatic factor, weather phenomena. It may be also due to the earthquake. This may be the very important. I would like to mention also that border road organization keep a record of such zone. So, improving our understanding where we have the more SASE. I think from the SASE website you can get. Now you can see here through this diagram I would like to mention that SASE has developed various type of technology to develop and protect the combating avalanche and other atmospheric hazards. Here you can see design of a snow gallery, a snow nets and a snow bridges, SASE has developed GPS based real time avalanche path warning and navigation system, So, best good idea also to see the NDMA website and the SASE website in order to know about the several type of the technique already developed by the people. Engineering structure is very important. Starting zone built massive earth of stone walls and terraces. These are the some of the important measures. Snow net constructed of steel cables, nylon straps, and held up by steel slopes. These are the some of the important examples. I think before any movement, I think these are the things we have to take. Precaution. As generally in the case of disaster risk reduction, is called the prevention is better than cure. Retarding structure are usually earth mounts. Direct protection structures are built immediately adjacent to the protecting wall. Avalanche shade or shelters are merely roof over the roads or railroad that allow avalanche to cross the road and railway without interrupting and threatening the traffic. As you know, most of the time in Uttarakhand and the Himachal Pradesh, Jammu Kashmir, traffic is disrupted due to this, and lot of the loss of life. I would like to also mention very quickly that the very few places we have the education, and I have here prepared some of the important the course structure also. Applied glacial geography, geography of the cryosphere, glacier system, remote sensing and data sources, tools and technique, mapping and monitoring glacier, glacier lakes, glacier hazards applied. So, what I am trying to bring before, we have to deal all in a very holistic perspective. Finally, I would like to say that collecting and compiling geospatial data, satellite information and local knowledge on avalanche, history and traditional response pattern very important. Challenging area continue to be modeling and risk prediction, activating early warning system, and particularly I would like to mention local and indigenous early warning system. Vulnerability assessment of critical infrastructure, strengthening communication link, integrating the scientific, technological, administrative and community agency, and focusing on preparedness and mitigation. Finally, I would like to conclude that a snow avalanche are major threat in a snow-clad Himalaya. Structural measures, improve monitoring through satellite and good weather forecast. We have to take geological and geotechnical investigation, disaster risk reduction, geoportal and web GIS, integrating risk assessment through mapping neighborhoods, event modeling and detection, and mobile-based ICT advisory to the people. Thank you very much.
With this note, thank you, sir. Thank you so very much. Thank you for connecting to us.